I will be giving an introduction to thermochemistry in this video. Thermochemistry deals with the idea of heat, also called enthalpy or energy. Heat is usually measured in joules or kilojoules. In a reaction, energy is either required or released. For example, this reaction here requires energy to happen. This is the reaction to turn water into water vapor. To do this, you would usually put water over a hot fire. The fire provides energy that allows for this reaction to happen. What I'm trying to say is that boiling water needs energy, which I represent by adding heat as a reactant to the overall reaction. This is called an endothermic reaction, a reaction that requires energy to happen. Now take a look at the reaction here. This is the chemical reaction for burning coal. Burning coal releases a lot of energy. After all, burning coal was how industrial machinery was powered. This is called an exothermic reaction, a reaction that releases energy. As you can see, one type of reaction consumes energy and the other type of reaction releases energy. Energy is on different sides. For an endothermic reaction, it's on the reactant side, and for an exothermic reaction, it's on the product side. Often, you'll see a graph with these two types of reactions. The graph will typically contain energy on the y-axis and time on the x-axis. It will have two flat lines, with one representing the potential energy of the reactants and the other representing the potential energy of the products. For now, ignore this bump over here. What I want to focus on is the change in energy of the reaction. Look at the graph to the left. This one represents the energy in an endothermic reaction. Notice the energy before and after the reaction has taken place. The energy after is higher. Why is that? Remember, an endothermic reaction requires energy to happen. If I am adding energy into the reactants to make products, then, logically speaking, my products should have more energy than my reactants. And this is what we see, an increase in energy. From where we started, there is a net gain of energy. We represent this by saying that delta H is positive, which means that the change in energy is positive. On the other hand, we see the opposite trend in an exothermic reaction. An exothermic reaction releases energy. If I release energy, think of it as losing or subtracting energy. That's why the energy of the products is lower than the energy of the reactants, since energy was released from the reactants. There's a net loss of energy. We represent this by saying that delta H is negative, which means that the change in energy is negative. I'm going to try and clear things up with delta H. Delta H represents the change in enthalpy or energy of a reaction. Because going from reactants to products in an endothermic reaction always requires the addition of energy, you will always end up with more energy than you started with. In other words, endothermic reactions will have a positive value for delta H. In an exothermic reaction, going from reactants to products always releases energy, so you will always end up with less energy than what you started with. In other words, exothermic reactions will always have a negative value for delta H. That's all for today. I will be making more videos on thermochemistry soon. Goodbye.